I can move them around like this. Boom, back to AI controlled. And then back to regular control. Back to AI. Hey YouTube, how are ya? This is Viper, and today we'll be building a reusable and extendable input management tool in Unity. This will allow us to speed up your development and give you a nice base pattern to control characters interchangeably with either user input or AI or even network. As with most tutorials, all code and assets used in this video will be available down in the description. So starting things off, we have a sample scene here. I have two characters, one that the player will control and one that eventually we want the AI to control. But the main concept here is we want to be able to control the AI-based one without any major changes to our main controller script. So if we take a look at the AI player here, get rid of this and this, we have just our character controller. Now the character controller, as you can see, if you're new to game development, or even if you've been around, you'll see controllers like this a lot. It has some components that tell us, gravity, move speed, jump speed, that kind of thing. Some properties that it needs to access to control other things. It handles input, deals with gravity, friction, and all those other nice things. So the main goal we're trying to accomplish here is this controls the main character just fine. But what if we wanted to make this same character be controlled by AI instead? Well, a lot of times what I see people do is they'll take their character controller and then just make it an AI character controller. And then instead of doing input.getKey, they'll go through some various sets of circumstances that might decide when to go forward, when to go left, when to go right, when to go backwards. So, you can still do that, but the problem is you lose all the control of the main character and the AI-controlled character. If you want to make a change to one of the pieces of code, like what if instead of going forward, you wanted to go up based on the camera angle? You wouldn't be able to do that by making the change in one area. So this is here to solve that. So in order to do this, we need two pieces of code. The AI controller, which will send the inputs to the input interface, and the actual input interface class. And if you're curious about this little dude down here in the corner, this is an overlay that I'm working on. They have a bunch of interesting details, but for now, they're just going to hang out and watch us make this tutorial. So, back to the tutorial. Let's hop into the input interface. So, based on what we're trying to do, we're going to need a few things here. We're going to need this could be public or private, but I'll do public for now. We need a public hash set of key codes, and this will be our current keys pressed. And then don't forget to initialize that. And then additionally, we'll need if I could spell properly, hash set of key codes, which is our previous keys pressed. I capitalize that for consistency, and boom. So this is so we can handle get key down, because in order to know that a key was down, we need to know that it was up on the last frame. And then additionally, we'll need one of these for the axes. So we'll go string float, and this will be our axis values. And then if you want to, I don't know if you'll need this, but I've done it before. You do a previous axis values. Great. So now we have all we need to set in order to make this AI controllable, but now we need to do the actual implementation. So first things first, let's implement the start method. The only things we really need to do in here are initialize these by adding whatever your axis may be. For this tutorial, we don't actually use any, but you might find this useful in the future. And something you can do if you didn't want to do this, just something to talk about while I'm doing this, is you could make a public list of strings that have the names of all your axes in them. And then instead of doing it like this, where you're manually adding them in start, you could just write a for loop or a while loop, and then loop through that list, add them all with a value of 0. But for now, we're just going to add those in. So let's make this actually work with the input interface. So we're going to need a public boolean get key. Pass the key code. And a very important boolean, which is AI controlled? Now this will denote if the player is controlled by AI or not. And if you were doing, for instance, if you're doing a network controlled character, if you want to further improve your client-side prediction, and you wanted to send the controls, not just like the physics of a rigid body or the velocity across the network, if you wanted to send the controls as well to further improve your client-side simulation over the network, you can do is network controlled as well. So in the get key, we'll say if it's not AI controlled and it's not network controlled, B is network controlled, then all we need to do is just return the main input dot get key, the key. And we can do else if is AI controlled. Now is where we actually use these values we've set above. So now we would just return the current keys pressed dot contains the key. And that's it. So now we have get key. Oh, I need to actually implement the else. I'll just return false for now. That else case is only if it's network controlled, which at the moment we can't actually do. So let's implement get key down now. So if it's controlled directly by the input, it's very easy. You just do input.getKeyDown. But in this case, we need to edit this a little bit. So if the current one is pressed down and it's not the case that the previous one was pressed down, then that's true. It was pressed down. Otherwise, return false. And then we could do the same thing for get key up. Simply change this to get key up. And then we need to reverse these. So if the key's not currently pressed, but it was pressed the last frame, that means the key's gone up. And just for good measure, let's implement the get axis. This will be get axis, and you pass a string, the axis. And then we'll do the same process again. Except this one is a bit easier. We just return input.getAxis axis value. Here, I messed up the indentation. We return the axis values at the axis. And the same if it is network controlled. Good. So one very important step before we end this one, or before we're done with this function, actually 3 steps. We need a late update. Now this late update is going to handle all these previous values for us. So these are no good to us unless we set them. And there's 2 ways to do this. What you could do is you could do an IEnumerator, and we'll call this set prevs. And all this will do is yield return new wait for end of frame, and then set the previous keys equal to the current keys, and the previous axis equal to the current axis values. Or we could just do it in late update. This is really on you. I found no problem with late update, but if you do have a problem with late update, you can do it so you're absolutely certain these are done at the end of the frame. But we could just plug this in here, and boom. Now get key down should work, get key up should work, and get key period should work. So we need 2 more methods in here. So public void clear. This is very important for your network or your AI controller, And this should always be called at the very top of whatever you have that's setting these values, because if it's not, whenever you set a key to be pressed down, it's always going to be pressed down unless you clear it. No, I know what you might be thinking. Oh, why don't we just do public void update and then, clear the press buttons and do this. That won't work, because depending on how Unity decides to run your updates, this update could run after your AI controller. And if it does run after your AI controller, your AI may say, I'm pressing W. And then this update runs, it clears that out. And then the final character controller updates, checks in there and says, you're not pressing W. And then knocks you out of there. And then it just does nothing. So we want to make it very explicit when this clear is called, and it's only ever called manually. And then we'll do another public void add key pressed. Key code key. Actually, I'll return a boolean from this. I don't actually need it in the script, but it's good if you need that information. Because a hash set can only ever have, if you know about hash sets, they can only ever have one of something. You can't add two of the same key. Excuse me. So this will return true if it added the key. It'll return false if it did not add the key. But that's all we need for the input interface. And before I even look at the AI controller, I'll show you how absolutely easy and seamless this is to integrate into your own existing controller. So we set a field for the input interface. In our start method, we get it. And then all you have to do is, instead of these inputs here, is replace it with your input interface. And now if we compile this and test, we'll be able to run this the same way we did before. So we need to make sure our there's an input interface on each one. And for now, we'll set them to not be AI controlled. Let's give it a shot. So, no change, all the characters move around. Great. But now, we go to our AI player and say they are AI controlled. You'll notice only the main character moves, only the one with the white shirt here. So now, we need to actually write the AI controller. To save some time, since it's not a very in-depth controller, I've taken the liberty of writing a bit of it beforehand. And we'll take a look at that here. So all this does is, once again, you get your input interface. In the start, you get a reference to it. And then in your update, very important, you clear it immediately. And then the rest, this is all personal. Whatever you decide to do, it's up to you. If you want. This is mainly purely just for demonstrational purposes. So I'm going to add an additional option here to jump, just to test our get key down. So all I'm doing is updating the random function, so it's either going to hold WASD or space for 1 second, every 1 second. And then all we're doing is calling that add key pressed function on the input interface, which is going to add it to our current keys pressed. Compile that. And let's take a look. Now, I'm not pressing anything on my keyboard. Let's see what happens when I add an AI controller to this character. They're moving left and right, left and right. Looks like the random function really likes those. Oh, now he's going back. I won't actually be able to see if he jumps. It looks like he hasn't decided to hit the jump option yet. But yeah, that's all there is to it. So now we've got, with absolutely no changes to our character controller besides changing the direct input to this input interface, this layer between that will decide send the AI control through or send the direct input through. That was the only change we needed to our core controller, and we can now control the same exact character through AI, or not through AI, if we chose not to. I can move them around like this. Boom, back to AI controlled. And then back to regular control. Back to AI. And this is a really, really nice reusable solution if you want your character, if you want to implement a client-side prediction over the network. So you can send a packet that contains that hash set of keys pressed and axes values. And then all you would do is you would probably add another script like a network receiver that interprets those and just sets them straight into the input interface. You make sure they are network controlled, and boom. Any input you make to that character, you don't have to change their controller script at all. But any input you send to them, they'll receive and act upon as if someone was directly controlling them. That's pretty much all there is to it. I'll thank you for watching up to this point. If you liked, be sure to leave a comment, like, subscribe, give me some feedback if you'd like to. I'm making more tutorials in the future, so keep an eye out for those. And if you'd like to see what becomes of our little helper here, be sure to subscribe too. I'll be making a video on them in the future. Thank you very much, and have a good day.